Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. My name is NUR MIZA binti RAZAK and in this video I'm going to present my bachelor degree project 1 and the title is Development of Shoes Dryer Using Controller with Internet of Things. My supervisor is Puan Noliana binti Abdul Muttalib and my panels are Sir Radi Hussein bin Ramli and Sir Lim Wee Tek. As introduction, shoes are important thing for human. A clean and comfortable appearance can give a person confidence in going through their day. Shoes easily become dirty and wet when exposed to rain or other dirty objects while the user is wearing them. So it needs to be washed and need to be dry for reuse. The main reason why shoes get wet quickly is because of its changing environment such as rain and slippery camping area that can make the shoes wet and dirty. This causes a user to have difficulty drying their shoes when it rains. A method often used by people to dry their shoes is place the shoes under the sun on hot day, but it is not impossible when the weather is suddenly rainy or in wet condition. This method also takes a long time and has to rely entirely on weather conditions to dry the shoes. Today there are many laundry services that wash shoes, but there are some laundries that need a long time to dry the shoes. To prevent this from happening, shoes dryer will be developed with several new features that simplify and speed up the shoes drying process without damaging the shoes. Problem statement. There are various methods that can be used in drying shoes such as drying the shoes under the sun or sending the shoes to a laundry service. Even with using that method, some problems still occur such as first, the color of shoes fade and damage occur to shoes that are dry under the sun. This is because the shoes dry under the sun can become damaged due to exposed to UV light for too long. Second, drying under sunlight is not guaranteed due to unpredictable changing weather conditions. Sometimes people leave their shoes in the backyard to dry the shoes under the sun in hope that the shoes will dry and they go to work for the rest of the day. With unpredictable weather conditions, it will rain at any time and the shoes will get wet again. Third, some laundry service take a long time. In the laundry service, people have to wait their turn if it's full or many people. So time will be wasted and they not being able to wear the shoes right away. Lastly, people who are busy with work do not have enough time to send shoes to a laundry service. And when going to camping or hiking, shoes easily get dirty and wet. Most dryer on the market are large and need to press a button on the dryer to start the process. So, a portable and fast dryer is much needed and users can also control the process with their smartphone. Objective: first, to investigate current shoes dryer in the market. Second, to develop the shoes dryer that is easy to carry and take short time to dry. Scope: there are several limitations in this project implementation. First, develop a shoes dryer that is easy to carry and easy to use with IoT. User can control the dryer with their smartphone. This blink system will act as a wireless communication to send the output on the smartphone and the user can start the drying process. Next, Blink server and ESP8266 Node MCU. Node MCU is as microcontroller used with Blink IoT to monitor and detect humidity and temperature level on shoes by using the HT11 temperature and humidity sensor. Third, Arduino IDE. It is used to write and upload programs to Arduino compatible board and carry out the drying process with the time requirement to dry the shoes. Methodology. So this waterfall have 4 phases. First, requirement planning. Second, system design. Third, implementation. And fourth, cutover. By referring to this methodology, the project can move smoothly and it will give an overview of the steps that need to be done in this project. First, requirement planning. During this phase, temperature and humidity sensor will be used to detect moisture and temperature on shoes. The temperature and humidity will be notified to the user and user can start the drying process by controlling with their phone. All the equipment required in this project is microcontroller ESP8266.MCU, DHT11, temperature and humidity sensor, fan, buzzer, heating element, phone and Arduino IDE software. Second, system design. Okay, in this case, I will explain the overall flowchart. First, the shoes are placed in the dryer. Shoes temperature and humidity are checked using the HT11 sensor. There are two conditions. If the humidity is at a level of more than 48% and the temperature is less than 36 degrees Celsius, the drying process will be start. And if the humidity and temperature of the shoes are at a good level, the process will not be carried out. And then data will send to the Blink server from the Wi-Fi modules and the user can find out the humidity and temperature level on the shoes. Then user can control the dryer by press the on off button on the Blink app. Okay. The shoes begin to dry the shoes begin to dry with the fan and heating element turned on until it reaches a humidity level less than 48% and temperature more than 66 degrees Celsius. If the temperature and humidity do not reach the desired level, the drying process continues. If the shoes are successfully dried, the fan and heating element will stop and a buzzer will beep to indicate that the process is complete. The data will send through the Blink server to the user and get notification on the Blink app. Okay, third, implementation. During the implementation phase, temperature and humidity detector will be developed and complete. Program code will be written in the IDE for a suitable and compatible microcontroller. Ensure that the moisture detector on the wet shoes can work properly and can connect to the notification application so that the user can receive notification. Lastly, cutover. Cutover. This is the final phase of the project planning methodology. Product testing will be done to see the output from this project is correct or not. Okay. Initial result. Blink application interface. Interface design is the initial design of the final product that the user will use. A good interface design is definitely user-friendly and easy to use by the community. Figure shows the design of the shoes dryer interface application to be used by the user. There is a temperature and humidity widget box on the interface for user to know the temperature and humidity of the shoes. Uh, so this is Arduino programming. Arduino programming is run to read temperature and humidity. The simple circuit is designed using the HT11 sensor, controller ESP8266 no MCU, jumper, wire and breadboard. The circuit is connected to the Arduino IDE and the coding is compiled to produce the output. Reading of temperature and humidity values are displayed on the Arduino serial. This is the initial orientation of the HT11 sensor. VCC is connected to 3.3 volt pin. Data is connected to D1 pin. Ground is connected to GND pin at node MCU. Circuit is connected to the PC and after run the Arduino, the HT11 sensor that connected to Arduino will detect the humidity and temperature. The reading of humidity and the temperature will be displayed on the Arduino serial. So this is the output display on the Arduino serial. Conclusion and future work. This product is very useful and will have a great impact on the exposed users on rainy days at time of need such as drying shoes at campground and workplace. The shoes drying process and evaluation of the level of effectiveness and speed of time taken will be conducted soon. Project planning. This is project planning for PSM1 and PSM2. That's all from my PSM1, and in PSM2 I will perform shoes dryer testing using developed system device and analyze the performance of the shoes dryer. That's all. Thank you.